Guys, it is April 20, well, it's the 27th, but this is your video for the 28th, so this is your 428 daily video. We're still in Unit 4, we're still talking about transformations. We're just going to add kind of another layer to this. So far, this is what you guys have been doing, right? I've been giving you a function. You've been identifying A, C, and D, and you've been telling me what A, C, and D are actually doing to the graph, right? We have a negative, so we flip. The absolute value of -3 is bigger than 1, so we have a stretch. Our C value is positive, so we're going to go to the left 4 units, and our D value is negative, so we're going to go down 1 unit. Same thing down here, our A value is that invisible 1, so we have no flip, we have no stretch or shrink. We have a -6, so we're going to the right, and we have a -15, so we're going down. So you guys have been doing this the last few days. We're going to continue to do that, but we're also going to add in another layer. So we can really easily, in words, explain what's going on here. The other layer to this is to actually show. Instead of just writing it, we're going to actually show what's going on. So if we were in class, I would have you guys draw this out. Obviously, that's going to be a little bit tricky because I can't really have you draw these graphs. So I'm going to give you some graphs and we're going to kind of match up. And I'll show you what I'm talking about a little bit later. But we are going to start looking at the actual graphs here. So I'm going to use this website called Desmos. You guys are welcome to use this. It's desmos.com. Okay. This is just a free graphing calculator. It's really easy to use. It's a really, really good tool. So I'm just going to hit start graphing. It's going to give you this setup as a default. If you would like to change it, I like to change my graph settings. So I'm going to go here. I don't like these little extra, they're called minor grid lines. I don't like these gray lines, so I'm going to get rid of those. And instead of counting by 2s, I want to count by 1. So that's called your step there. So that looks a little bit more like what you're used to. So I'm going to go ahead and include my parent function, which is the square root of x. And I'm going to give that to you, I'm going to give that to you in red as a red dotted line. Okay, and I'm going to leave that in there just so we can see, because remember, a transformation is a shift or a change from our parent function. So here's our parent function. Something else I'm going to add in here is our vertex. Our vertex, we've worked with the word vertex before, but it's going to be kind of just our starting point. Okay, our high or low point, right? This is the lowest point on this graph. The parent function starts at 0, 0. It starts right here at the origin. So I'm also going to plot that point just because it makes this easier to see. So I'm going to change this. I'm going to make it red. Okay, and I'm going to leave those two things in there. So basically, I'm just going to use this tool right now to show you what all of the different transformations look like on a graph. Okay, so from this over here, we know that when A is negative, we get something called a flip. Okay, so I'm going to show you what a flip looks like here. Okay. If you're using this and you want to type in square root, you just type in SQRT, and then it types that in there for you. Okay. So we have the square root of x, right? That's our parent. Now let's look at what happens when we make this negative. So I'm going to include a negative sign over here and watch what happens with our graph. So as soon as I add in this negative, there's our flip. Okay. So instead of going up and over, now we're going down and over. For the purposes of this class only, this class, this semester, your graphs will always go to the right. Okay. You, in this class, this semester, are never going to get a graph that shoots off to the left here. All of our graphs are going to be pointing to the right. Graphs that point to the left do exist, but not for our class. You got to go take Coach Matt's pre-calc and trig class. So for this class, everything's always going to go to the right. And this shape isn't really going to change. We're going to go up and over. But instead, when we have a flip, we're just going to go down and over. Okay, so we have no flip, flip. Positive, negative. No flip, flip. So the flip is pretty straightforward. Okay. We also have something called a stretch and a shrink. So We know that when the absolute value of A is bigger than 1, our graph stretches out. If it's smaller than 1, it shrinks down. So let's go ahead and look at just a stretch on its own. So I'm going to say, let's just go ahead and stretch this by 3. As soon as I make that A value with an absolute value bigger than 1, our graph gets taller. So it stretches out. It's like there's a string here and we just pull it up, we stretch it taller. And it's just because everything is getting multiplied by 3. Okay, so here we have 1. If you multiply that by 3, it jumps up to 3 here. Okay, normally we have 4, 2. If you multiply that 2 by 3, we now have 4, 6. Okay, so everything is just getting multiplied by 3. So it's getting taller. So this is a stretch. Okay. As soon as we add in that big A value, we get a stretch. So if you notice, we haven't moved from the origin at all. The graph has just gotten taller. Okay, so no stretch, stretch, no stretch, stretch. Original, parent function, transformation. Okay. We can also have a shrink. Shrink is basically just the opposite of this. So let's go ahead and say I make this less than 1, my absolute value less than 1. So for example, if I make this 0.3 instead of 3. So let's go 0.3. Okay. Now what we have is our shrink here. So if you notice, now the graph has just been like pushed down. It's a little bit shorter. So we went, here's our parent function. Here's a stretch. And then, right, here's our parent function. Here's a shrink. So the shrink is just a lot flatter. So the stretch is very tall and stretched out. The shrink is just very flat. Okay? And I'll try to make those really obvious for you when you're looking at these graphs. So from A, right, we had a flip where we just pointed down, right? We had a stretch where our graph gets taller, and then we had a shrink where our graph gets smaller. Okay, and remember, all of this is just from the parent function. Okay, so that's everything you can get from A. And then remember, you can also have a combination of these. Like we might have a flip and a stretch, right? So a flip here would be, we're pointing down, and then a stretch would be, okay, we also got really tall. So this would be a flip and a stretch. Notice how it's upside down and it's way stretched out, it's much taller, right? So we can also have a flip and a stretch, or we could also have a flip and a shrink as well. So we have a flip and a shrink, right? Where we are upside down and we're like just squished down a little bit shorter as well. So we can have those combinations. We could have just a flip, and then we could have a flip and a stretch, or we could have a flip and a shrink as well. Okay. So that's A. We also know that our C and D values change what's going on. So we know that C shifts us left and right, yes, but opposite. Normally, a negative goes to the left and a positive goes to the right. Counterintuitive, flip that around. So let's say we have a +3 here. So +3, right, from our examples over here, we know that a +4 is actually going to shift us to the left. So here's what that looks like. Let's say we have +3. Whoa, +3. Okay, so if you notice, all that happened was from my original parent function here, everything just shifted over to the left 3. The graph's shape didn't change at all, just its position did. And you can also see we have a new vertex, right? We're no longer at 0, 0. We're not starting at 0, 0 anymore. Now we're starting at -3, 0. So this actually changes the starting point for our graph as well, right? So we can shift to the left from a positive, and we can also shift to the right from a negative, okay? So that's your left and right. That one's pretty straightforward. If your vertex has moved left or right, that's coming from your C value. So wherever your vertex is, will tell you your C value, right? We have moved to the right 3, We can move to the left 1, would give us a new vertex at 1, negative 1, sorry. We can move to the right 5, 51. 5 would give us a new vertex at 5, 0. Okay, so left and right is just going to move us along the x-axis. And then the last part of this is your d value. Okay. Similarly, your d value isn't going to change the shape of the graph at all. It's just going to bump it up and down. So for example, if we have d value as positive 3, we're just going to jump up 3. Notice again, this does give us a new vertex here at 0, 3. Okay. And we can also shift down, same thing, where our graph just jumps down. Okay. So up and down, pretty straightforward. And then we could also have a combination of left and right and up and down. So for example, if we have a shift to the left 2 and down 3, notice how we have now our vertex, right? Looking at the starting point, we've gone to the left 2 and we've gone down 3, right? So if we have, for example, a shift to the right 4 and up 4, for example, now we have a new vertex of 4, 4. Okay, so now we've gone to the right 4 and we've gone up 4. So if you put that all together, right, we have these graphs that are all based on this right here, but have all these like special changes. So let's go ahead and look at this one right here, actually. I'll type this one in. So let's look at this example here. I don't know if this screen setup is going to work very well. Okay, so we have f of x equals negative 3 times the square root of x plus 4 minus 1. Okay. Notice what happened here. We know there should be a flip. And in fact, yes, our graph has flipped over. It is upside down, right? It did flip over. We should also have a stretch, right? Our graph should be a little bit taller. Yeah, it is. We can see that this graph is stretched out a little bit more than the original. Okay. We should also have a shift to the left, which we did. We went left 4 and a shift down, right? So we went left 4, down 1, giving us that new vertex of negative 4, negative 1, right? So you can see that point on there. So that's how these all work together, right? You can identify them. Yeah, we flipped, we're upside down. Yes, we stretched out, it's much taller. Yes, we went to the left 4. Yes, we went down 1, okay? Looking at this second one here, we can also take a look at that one. For example, f of x equals the square root of x minus 6 minus 15. It's going to disappear because it's way down here. Okay, but this one moved us to the right 6. Okay, so we have no flip. Yeah, it's still pointing up. We have no stretch or shrink. It's still that same. It's not taller or smaller. It's still the same. Okay, and we went to the right 6 and we went down 15. So that's how all of these work together. Okay, and then the vertex is just helpful because you can see it a little bit better, right? We went from 0, 0, and then we went to 6, negative 15. So you can see that shift to the right 6 and down 15 really easily. So some problems that you might see that I might give you would be something kind of like this. Where I would give you the picture of a graph and then I would ask you to write out in words what's happening, right? So on this one we can see that there's a flip. We can see that it's not very tall or very small. I'll try to make that super obvious for you. And that we've gone to the right 3 and we've gone up 1, right? Similar on this one, we can see that this one is very tall. It's not flipped over, but it is stretched out. And we can see that it moved to the left 1, but it didn't go up or down at all. So this one just has a shift left. Okay. Same thing on this one. It's not upside down, but it is very, very, very small. It's shrunken down, so we have a shrink there. And then you can see that we shifted to the left 2, or the left 3 and up 2. Okay. And then I might also give you them backwards, right? So where I would give you I might give you just this portion, or just this right here, right? And then I'd give you 4 graphs, right? And I'd ask you, okay, which graph shows a flip, a shift to the right, and a shift up? So those are the types of problems that you'll see on this. You can always start by just writing out what's happening, and then it makes it really easy to, match the graph, pick out which graph you're looking for, right? I might give you this right here and then ask you, okay, which graph shows this function? Which graph actually shows these transformations? Or I might give you the picture and ask you to write the transformations from that. So same idea, nothing is really changing, but instead of just looking at the words and the numbers, now we're looking at the picture as well. So we're just gonna take everything and put it all together. So if you have questions, please let me know. We'll do office hours on Wednesday and Friday this week. We will have a summative coming up at some point soon. I'll let you know on that. But for now, head over to Google Classroom, daily assignment. Please let me know if you need help. Otherwise, you guys are off and good to go. Nice job.